Okay, question number 23 was as follows. The diagram below shows the speed time graph of a moving object. So I urge you to pause the video and then look at the graph given. Make sure you take note of the highest speed, the speed where the object started moving, as well as the time given. Okay, you need to take note of that. Okay, once you've done that, then let's come to question 23a. Question 23a, they're asking us to find the acceleration of the object when time is equal to 3. Okay, so first of all, let me give you the formula to find acceleration. So acceleration is equal to final velocity minus initial velocity. Okay, that is v for final velocity, and u, that is initial velocity, divided by time. Okay, so what we're going to do now is I'm going to write equal to, then here is what you need to understand. They are telling us to find the acceleration of the object when the time is 3 seconds. Now when you look at the graph, there is nowhere 3 seconds is indicated. However, 3 seconds is between 0 and 5 seconds. Okay, 3 seconds is between 0 and 5 seconds. So I can show you that the line blue there is indicating almost the place where 3 seconds should be. Okay, now if that is the case, how can we tell the velocity of this object when also the speed at which the object is moving at 3 seconds is not even shown? So here what you need to understand is this: from 4 to 24 meters per second, from 4 meters per second to 24 meters per second, you can see that the acceleration was constant. Okay, the acceleration was constant. The object was changing the speed at a constant level. So that means we can use any point to find the acceleration of this object. So in this case, we're going to use the starting point and the finishing point where this change in speed changed. Okay, where this acceleration changed. Okay, so what I mean is I'm going to come up with we said what was the final speed, velocity of the object. We are saying it's 24. So I'm going to subtract 4 from 24 because the initial velocity is 4 and the final velocity is 24. So I'm going to subtract 4 from 24. So I'm going to come up with something like this. Okay, I'm going to come up with something like this. The red line there, which is on the slanting line, that one is showing the acceleration there was just constant. The change in velocity was just the same. So I can use any point, just like I've used 24 minus 4. Then the time it took from that point to that point, it is 5 seconds. So it will be over 5 seconds. Okay, once I've done that, then the next thing I'm going to do is I'm going to write equal to. So I'm going to subtract that. 24 meters per second minus 4 meters per second will give me 20 meters per second over 5 seconds. Okay, which is equal to, so when I divide 20 meters per second by 5 seconds, it's going to give me 4 meters per second squared. Okay, it's going to give me 4 meters per second squared. So this was the acceleration of the object between 4 meters between that point and the final point. Okay, so this was the acceleration. It was 4 meters per second squared. Let's go to question 23b.